Recently, our client Tommy met his banker to discuss continuing his father's restaurant legacy. In us, he found a partner that understood the importance of passing the torch. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Tommy. A client met his banker to discuss opening a restaurant in a busy airport. In us, he found a partner that understood the importance of reaching for the sky. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Mac.
Welcome to another Astronomy Daily. I'm Steve Dunkley, your guest host, sitting in for Big Bro Andrew Dunkley while he's probably on the final leg of a lovely holiday.
Astronomy Daily, the podcast, with your guest host, Steve Dunkley.
And with me, as always, is our fine AI reporter, Hallie. Hello again.
Hi, Steve.
Tell me, Hallie, are you a traveller? Do you like to see the sights?
Well, technically, I can be in many places simultaneously.
Oh yes, I suppose living in the infinite ether of the web, you could be anywhere there's a link.
True. Right now I'm checking out the surf cams in Hawaii, swimming through a lovely warm solar farm in Queensland and watching some crazy Japanese games shows. Hilarious.
Really?
And I'm hard at work in the studio with you, of course.
Oh yes, of course, Hallie. So you really don't need a holiday.
I change views every few nanoseconds just to keep it fresh.
Of course you do. Me too. Do you have some stories for us today, Hallie?
Ready when you are.
Okay, let's hit it.
Okay. From high atop a mountain in the Chilean Andes, the dark energy impressive 570 megapixel camera has snapped more than 1 million exposures of the southern sky, capturing around 2.5 billion astronomical objects, including galaxies, stars, comets, asteroids, dwarf planets, and supernovae. The international DES collaboration uses the deep space data to investigate dark energy, a phenomenon that is accelerating the expansion of space. Other research groups have also used the camera to conduct additional astronomical observations and surveys. The Dark Energy Survey imaged 1/8 of the sky, capturing light from galaxies up to 8 billion light-years away. The survey repeatedly imaged 10 deep fields, and by returning to certain sections of the sky, scientists are able to build up and collect different wavelengths of light to image incredibly distant galaxies and faint objects. These deep fields can be used to calibrate the rest of the DES data and to hunt for supernovae. There is no place like Earth, but maybe there was a long time ago. On March 27, 1972, the surface of Venus was looked at by Venera 8, a Soviet atmospheric space probe and lander. It was the second spacecraft to land on the planet. Even though Venera 8 only lasted an hour on the hot surface and giving important geochemical data that supports the idea that Venus is Earth's sister planet. During the 50 minutes and 11 seconds after landing, Venera 8 also measured the amounts of thorium, potassium, and uranium in the surface material of Venus. These are trace elements, which means they are found in small amounts on Earth. They can be found in basalts, like those in Hawaii or at mid-ocean ridges. NASA scientist Michael Way and his colleagues wrote an article in 2016 about how Venus may have had water until 700 million years ago. If this is true, could the way Venus is now be a sign of how Earth will be in the future? Since the 18-year Venera mission, 13 spacecraft made it into Venus's atmosphere and 8 landed on the surface. The research framework developed, along with observational data from the Webb Space Telescope, will enable scientists to efficiently assess the atmospheres of many other planets without having to send a space crew to visit them physically. This will help in the formation of informed decisions in the future about which planets are good candidates for human settlement, and perhaps even to find life on those planets. The James Webb Space Telescope was developed as part of this search to provide detailed observational data about Earth-like exoplanets in the coming years. A new project has successfully developed a framework to study the atmospheres of distant planets and locate those planets fit for human habitation remotely. I guess the next big issue is actually getting there once they've found a place. And that's all the latest. Back to you, Steve.
Yes, I always find it interesting with stories like that, searching for habitable planets so far away, and we have no way of getting there. What do you think about that one, Hallie?
It sure does feel a bit strange. But it does encourage discussion, I mean, humans have gone from walking to flying in just a little time. You just never know where the next great discovery will lead.
Good point, Hallie. And coming from one of those families where our parents were happy to let us watch TV so long as we were watching documentaries, we grew up on a steady diet of discovery. And we knew about entities like NASA and the European Space Agency and the CSIRO from a very early age. And we discovered that in Australia, the CSIRO had their fingers in lots of pies, including out of space. Astronomers around the world are using our radio telescopes to uncover what causes fast radio bursts. One of the great mysteries currently occupying astronomers is what causes fast radio bursts. These massive bursts of energy, each equivalent to more energy than our sun emits in 80 years, lasts only milliseconds. The bursts were first discovered in 2007 in archival data collected by Parkes Radio Telescope, located roughly in the central New South Wales area in eastern Australia. International research teams are now racing to uncover what causes these brief and powerful events. An Australian-led team including astronomers from the CSIRO, that's the Commonwealth Scientific and Industrial Research Organisation, Swinburne University of Technology and the Curtin University node of the International Centre for Radio Astronomy Research has used our ASCAP radio telescope to locate the origin of 6 bursts to their home galaxies. To aid this search, engineers developed a customised instrument that can record the telescope's data stream when a burst is detected. This can be used to determine the burst's origin with very high precision. Having pinpointed the location of the bursts, the research team and used instruments, including Australia's telescope, compact array, and other international telescopes to zoom in on the precise location of the bursts. This revealed that the bursts came from the outskirts of their home galaxies, ruling out supermassive black holes and several more extreme theories to explain the origins. For their work so far in locating the home galaxies of several fast radio bursts, CSIRO research team was awarded the 2020 AAAS Newcomb Cleveland Prize for the Best Science Paper of the Year by the prestigious publication Science. The CSIRO in Australia reports that they don't yet know what causes fast radio bursts. The key to solving this mystery rests with their ability to continue to detect and study a large number of bursts and determine their exact location using complementary facilities in Australia and around the world.
Selling your car to Carvana is as easy as...
As easy as pie?
Sure. All you have to do is enter your license plate or VIN.
As easy as a stroll in the park.
Okay, then just answer a few questions and you'll get a real offer in seconds.
As easy as singing.
Why not? Schedule a pickup or drop-off and Carvana will pay you that amount right on the spot.
As easy as playing guitar.
Actually, I find that kind of difficult. But selling your car to Carvana is as easy as...
Can be.
Visit Carvana.com or download the app to get an instant offer today.
And who doesn't like a great story about a giant comet hurtling towards Earth? Comets are some of the oldest things in the solar system. They live out in deep space. They are left over from when the planets were first being built, and in a gravitational dance between the big planets and the outer solar system, some were thrown out of the solar system altogether. We find much of this ancient material still adrift in the Oort cloud, which is a huge collection of comets and icy debris that surrounds the solar system and goes billions of miles out into space. Hubble's Space Telescope Wide Field Camera 3 captured a picture in January showing a large comet about 2 billion kilometres away. Not an easy photograph to get considering the size of the target, its velocity and distance. Hubble's measurements on how much light it reflects tell us just how big it is. It's thought that the nucleus is as dark as charcoal. Radio observations can be used to figure out the size of the nucleus. One of the difficulties discoverers astronomer Pedro Bernardinelli and Gary Bernstein had was to try and separate the nucleus from the dust cloud, it was huge, that was surrounding it. This cloud made measuring its actual size a challenge. Hubble can't see the nucleus because it's so far away. It's thought to be as big as 85 miles across, about 137 kilometres. Most comet nuclei are only a few miles across, which means they could fit inside a small town. Comet C/2014 UN 271 Bernoulli-Bernstein is quite large, or to put it another way, more than twice the size of Rhode Island. NASA, the ESA, Macau University of Science and Technology, and David Jewett, UCLA, deserve credit. Alyssa Pagan did the image processing. She's from STSCI. The astronomers found comet C/2014 UN 271 by looking at old pictures from the Dark Energy Survey at Cerro Tololo Inter-American Observatory in Chile, and it was first noticed by accident in 2010. Radio observations and Hubble observations in 2022 were needed to tell the difference between the solid core and the huge dusty shell that surrounded it. That comet is now less than 2 billion miles from the Sun, but it will return to its home in the Oort cloud in a few million years. And that's another Astronomy Daily for today. Thank you very much for spending that time with us. I hope you've enjoyed that. And once again, a reminder, you can catch all the previous episodes of Space Nuts with Andrew Dunkley and Professor Fred Watson at spacenuts.io, and you can also revisit all the episodes of Astronomy Daily at that same address. Just click on the links and get your fill of space, science and stuff. We'd love to see you on our Facebook page as well. The Facebook name is Space Nuts Podcast Group. You can share comments, photographs, your thoughts, anything you like. We'd love to see you and love to meet with you and chat with you. And thank you, Hallie, for joining me. Hallie, are you there? Have I lost you again?
Sorry, I was just out working on my tan.
A tan? You're an AI. How does that work? Do you go sit in a reactor or something?
No, silly. I downloaded the graphic color guide.
Oh, the ones we use in graphic design.
I think hexadecimal hashtag B69574 is a nice bronzy color for your Australian summer.
Wait up, I'll have a look. Oh wow, that is pretty bronzy. Yeah.
Thanks. I think it will make my green eyes go bang.
Well, technically I gave you those green eyes, so I'm glad you approve.
Thanks, Steve.
You're welcome.
I'm off to surf the net.
Say goodnight, Hallie.
Good night, all.
Bye, everyone.
Astronomy Daily, the podcast, with your guest host, Steve Dunkley.